All right. Welcome to the lesson 1.1 on parent functions and transformations. So this is the notes you should see in front of you. If you have something different, then you need to check and make sure you clicked on the right link. But we're going to be going over transformations sort of throughout the entire year. So when we start on day one talking about transformations, it's generally going to be pretty basic and graphs that you are already familiar with. You should be familiar with the following graphs. Constant graphs, which are just straight lines, no slope at all. Linear, which would have a straight line as well, but going up or down. The absolute value, probably you're least familiar with, but it is in the shape of a V. It goes down on up on one side, down on the other side. And then the quadratic, which is in the shape of a parabola or a U-shaped. We'll also get into domain and range a little bit later. Today, we're just going to look at, okay, let's compare what we see to the parent function, and then let's see if we can kind of describe what has happened. It's pretty basic. By changing anything within these functions, adding things, like if I took a linear function and instead of it being x, I did x plus 1. Okay, well, that changes the graph. If I did 5x instead of x, that would change the graph. All these things that you can manipulate will change how the graph behaves. So this right here, this is not in your textbook or anything like that. This is something that I've kind of just made up on my own. This is a general, and what I'm referring to is this here. This is a general formula for how you determine what is happening to a function. So all functions, whether they're lines or absolute values or quadratics or whatever, will follow this general formula. It won't look exactly like this every time. Quadratics will have like a little square right here. Absolute value have bars. So it does not look exactly like this, but this is a general rule, meaning that anything that is on the outside here, we refer to as A. What that's going to do is cause a vertical stretch or a vertical shrink, meaning the graph, if you think of something being stretched vertically, it's going to get thinner and it's going to get steeper. If you think of like you had one of those stretch dolls or something like that, or stretch things, or putty or something like that, when you go to pull it and stretch it, it does get skinnier and also gets kind of steeper, more vertical. B, we're not going to really use B in this class. You'll see more of that in pre-calc, but this is your horizontal stretch and shrink. Again, we don't really see that. Oh, one thing I forgot to mention with A too. If there's a negative out here, that does cause a reflection across the x-axis, something that would flip vertically, a vertical flip. Always remember A is vertical, whether it's vertical shrink or stretch or vertical reflections. B, again, we don't use in this class, but it is horizontal stretch and shrink. It's also a reflection across the y-axis. So if you do see a negative here on the inside, that would reflect across the y-axis. And then we get into our shifting here. C here is a horizontal shift left and right. One thing you'll need to take into account here is there is a minus sign there. So whatever the shift, whether it's left or right, will always be opposite because of this negative sign. So if you see -3, you might think that goes left 3, but in actuality it goes right 3. And that's just because whatever number in here has to take into account the negative. So it's actually doing opposite of what you think it would do. And finally, D is your vertical shift up and down. This one doesn't have a negative there, so whatever it says is what it does. So if it is +4, it will go up 4. If it's -4, it will go down 4, just like you would think it would. An easy way to remember these, what's on the outside always does vertical actions. What's on the inside always does horizontal actions. We're going to go over several types of graphs. We'll get into parabolas in the next unit, but today we're going to focus on the first 3 here, which is constants, lines, and or linear and absolute value. So the first thing we're going to look at is a line. This is a linear function, and the parent function is simply y equals x, or f of x equals x. So that is a basic line. That's the parent function. Everything I do will manipulate this function, flipping it, making it steeper, making it go shallow, more shallow, all that stuff is going to move it up and down, left and right, all that stuff is going to happen to this function. Now, so what we're going to do is we're going to show these here, and I'll use these in different colors so you can kind of see. The first couple examples here, you're going to notice in these there is no x, so we would call this a constant. And so the transformation simply is just going to be straight across. It's going, I mean, these are weird ones. These constant ones are weird ones. But it's simply going to be straight across. Since it is a 2, what that means is that, and let me color code this. Let's do blue. This would be a constant of 2. It would just be a straight line across. F of x equals 2. So that's just going to be up 2. That's it. And the same thing happens here. Let me change this color so it's consistent. I don't want to convert it. I want to style. There you go. Make it so it's consistent there. So now let's look at a different one. Let's change colors here. This one here is a -3. Again, there's no x, so this one's going to be another constant. Oh. And since this one's -3, this would be simply down 3. And so this would look just like this. So f of x equals -3. Now we start getting into our linear functions. So one thing you're going to notice here, if you're trying to look at and go, hey, wait a minute. So if I'm supposed to be like looking at this, where are those parentheses or anything when I'm looking here? So actually, with linear functions, you don't have this middle part. This middle part's gone. So when you're dealing with linear functions, this is not here. And let me make this a little bit bigger. When it's linear, this, well, I should not say that. You don't have B and C. Okay? And so there will not be any horizontal shrinking and stretching. There will not be any horizontal movement. Everything will be vertical stretching and shrinking or flipping, because if it's negative, and everything will be shifting either up or down. There is no left or right. There is no horizontal stretch or horizontal shrink. So essentially, these are gone when you're dealing with linear. So when I go down here, you'll notice first here, and let me change back to my font here. Notice first of all, there is no A, so nothing is going to change with A. There is an A, it's just 1, so nothing changes there. And then you have your D. D does vertical shifting up and down. Since it's -6, this simply is going to be down. This is, by the way, linear. Down 6. So when we go down here, we know basically what we are essentially doing is taking the line that's right here, and all we're doing is moving it down 6. So now the line will be down here going through -6, and then going up 1 over 1 in both directions. And so that is a movement of down 6. So F, that's not an F, x minus 6. And so we could do this with all of these. We'll do a couple more here just so you get the idea. I'm not going to do all of these problems, but just so you can kind of get the idea. So here you'll notice that this one, let me change colors again. This is going to get kind of crowded on my line up there. Let's go with gray. This is again linear because there's no absolute value and there's no x squared. So this is linear, but notice how the change to the a and change to the d. A slope of 2 instead of having a slope of 1 should make it steeper, making this a vertical stretch. This is a vertical stretch. If I could spell, that'd be awesome. By a factor of 2. And then with the plus 3, you also have and up 3. Or you can say vertical shift up 3 or vertical shift positive 3. Same thing with the green one there, h of x. You could say that that's a vertical shift down 6 or vertical shift of negative 6. However you want to word that is fine with me. And so we have it getting steeper by a factor of 2 and then shifting up 3. So going back to our basic line here, instead of going up 1 over 1, now it's going to go up 1 over 2. It's getting steeper, but then also shifting up 3 units. So 1, 2, 3. So now it's going to be right there and right there. So now we can go in both directions. There you go. And so that's the shift. It's gotten steeper, but then also shifting up 3 units. So this would be f of x. I know it's not f of x. We changed the letters and all of these, but this is 2x plus 3. And so what we would see then finally on the last one, let's change this color for the last time here. Let's make this kind of a purplish color. When you have a negative out front there, you do get a flip across the y-axis, or sorry, x-axis, and then you do have a shift up. So what this is going to do is instead of being positive 1, it's going to be negative 1. So this is a reflection. Oh, by the way, this is linear. This is a reflection across the x-axis and just up 1 or vertical shift up 1, vertical shift plus 1, however you want to word that. So what this is going to look like now with this, instead of going up, it's actually going to be going down 1 over 1, but then also it's being shifted up 1. So these dots are just going to shift up 1, and so now I have, oops, not what I wanted to do. And this is f of x equals negative x plus 1. Really a lot of stuff going on there, but hopefully you get the idea of what's happening there. Moving on to absolute value, again, we're not going to do all of these. I do want to show a couple of them here, but there is your parent function. This parent function, and let me go back to the basic red, is f of x equals the absolute value of x. So standard slope of 1 in both directions. You'll see it goes up 1 over 1 to the right and up 1 over 1 to the left. Standard function in the shape of a V. Now, when we put a 2 out front, the bars will act like these parentheses. Now with absolute value, we open all of this up. So with absolute value, what this would look like is just instead of parentheses, you have bars. But everything's open here in absolute value. Anything can happen. So it looks like in this first one, we simply just have the A, a vertical stretch or vertical shrink. In this case, because it is positive, it is a vertical stretch of 2, which means instead of going up 1 over 1, it's actually going to go up 2 over 2 in both directions. So you get a V that looks kind of like this, as I'm going to sketch this kind of roughly, but that would be what it looks like. And so this would be a vertical stretch by a factor of 2. The g of x would be stretching by a factor of 3, but then because of this negative, you do get a reflection across the x-axis. So what that means now is it's going to have going up by 3, a slope of 3, but then upside down. So now, instead of going up 1 over 1 kind of in this direction, it's going to be going by 3. So you'll actually have it here and here, very steep, but also upside down. So we would call that a reflection across the x-axis, and then a vertical stretch by a factor of 3. I'm not going to write all that down. H of x is pretty simple here. You do have this being acted on C and D, which means all we simply have is a shift horizontally and shift vertically. You have to be careful here, as I told you before. Inside here, this is the only weird one. It looks like it's -6, so you might think that this goes left 6, but it doesn't. Because of the negative sign in the formula up here, it actually manipulates it in an opposite fashion. So instead of it going what you think would be left, it's actually to the right 6. And this would be up 2. So the transformation would simply be to the right 6 and up 2. Simply, that's what you could put. Or you could say a vertical or horizontal shift to the right 2 or 6, and a vertical shift up 2. But I'm not going to write all that. It's simply right 6 up 2. Let's get this so we get it nice and clear. Right 6 and up 2. Let's make this a different color. Right 6 is over here. Up 2 goes right here. So now I have exactly the same V, just going just over 6 and up 2, like that. Actually, that goes out there, but I just don't want to run into. That's to the right 6 and up 2. Here, again, you have C and you have D, so you do have a shift to the right, or sorry, this would be a shift to the right, but it's not actually. It's shift to the left 3 and down 3. But also you have manipulation to the A, which means this is going to get steeper by a factor of 2 because it's more than 1. If it were less than 1 or a fraction or a decimal or something like that, then it would shrink. But this is going to increase the slope by a factor of 2. So this one looks, this is about as much change as you would imagine, or what you can imagine you would see here. But we have a movement left 3, down 3. So left 3, down 3 puts the new vertex right there. And then instead of going 1 over 1, it actually is 2. So instead of going up 1 over 1, it's actually up 2 over 2, or up 2 over 1. And then we can draw the graph. There it goes. Something like that. And then finally, the last one here, you will have a reflection. So this should be upside down. You will have a horizontal stretch, or sorry, not horizontal stretch, horizontal movement. You'll also have a vertical movement component there. But notice how none of these have anything in the B spot. That horizontal stretching and shrinking is just not there. We don't do it in this class, but you will see that in pre-calc. And that's it for linear and absolute value, and that's really all you do. With these graphs down here, we'll go a little bit quicker now. You're just going to identify what type of function it is and then compare it to its parent function. So this is obviously going to be linear. But then what has happened to it? Well, we know that a linear one goes like this. So obviously it's been flipped. So we have a reflection. Just because it's not across the x-axis doesn't mean that it wasn't reflected. The fact that the line is now negative, this part right here is negative, that means that you're going to get a reflection across the x-axis. So don't just go based on looks, look at the actual equation. The 1/4 is also a, because it's in front of the x here, it's less than 1. So this is going to actually be a vertical shrink. So a vertical shrink by 1/4, whatever number's there. And then you do have a D that is here. Notice that there are no parentheses, there are no bars, nothing. So remember what I said, you don't have B and C ever with linear. You only have A and D. When you get to absolute values, like 3 or 4, when you get to quadratics, then you start taking into account horizontal stuff. But with lines, with linear ones, it's just A and D. And so because of that positive 8, that is up 8. And those are all the things that happen to it. The number 2 is a constant. Because it is a straight line with no slope, there's also, as you'll see here, no x. Because it's -3, the transformation simply is down 3. This is a v, so this is absolute value. You can also tell by the bars that are there that this is an absolute value. And then all you have is this thing on the outside here. You just have a transformation in the A spot here, which is just simply a vertical stretch by a factor of 5. With parabolas, again, we're going to go over this a lot more later, but this is the same thing here. There is no A. You just have C and D. So you're just going to have left and right and up and down. So remember that that's opposite. So it's not left 1, it's actually right 1, but this is a quadratic. You'll not be tested on quadratics in this unit. That'll be in the next unit. But it is right 1 and simply up 4. And that you should be able to see that when you look at the graph here. You can see that it has been moved right 1 and up 4. Right, last problems here. We're not going to do all of these. Well, maybe they don't take that long. Graph the function and its parent function. Okay, so first of all, you need to recognize with this right here that this is linear. So the parent function is a line that just simply goes right through the origin diagonally, just like this. That's your parent function, f of x. The new one, because this is got -7 here, that is your D. That is going to be down 7. So simply, this will go down. This is going by 2s. So 7 will kind of be in between these. But it is the same slope, same line, same everything. Just shifted down 7. You may change colors on that or whatever you want to do, but that'd be your new function. -9, there is no x here. So this makes this a constant, which just is simply a straight line straight across at -9, which runs right through the middle here since it goes by 2s. So that is down 9. Absolute value, I should draw the parent function. The parent function for a constant is just the x-axis. With absolute value, we could draw the parent function. It's just a v going up 1 over 1 in both directions. That's the parent function, f of x. This right here is an absolute value. The only thing that's happening here is this on the outside, which is your d, which makes it go up 1. Let me do this in a different color. So up 1, since these lines go by 2s, it's a half there, but then you'll see up 1 over 1, up 1 over 1, like that, and that will be your shift in your function, up 1. That is transformations, just basically being able to recognize what they are, what their parent functions are, what's happening to them, what kind of transformation is happening to them. That's what we do today. What we do next class is get into a little bit more complicated stuff where you're going to actually have to write the functions. They're going to give you the transformation and you will have to write the functions. But until then, hope this helps.